Hello, everybody. Welcome to IAB Open. My name is Mia Kulevind,
And I'm Tommy Polly.
and as we have a full agenda, we start right away with the Note Well, of course. This is an IAB meeting, but we are part of the IETF. So the Note Well applies similar as in every meeting. Um, we might not have any discussion that impact IPR rights, but this is the important part. But also be aware of the code of conduct, and let's have a nice session. Probably you've seen the slides also a couple of times. So everybody in the room should join the Meet Echo client in order to have a record about who was here, important for standard setting. Then remote participants, you're very welcome to have your video when you're talking, but otherwise you should not join with the video probably. And also if you want to join the queue, then you have to use the Meet Echo client. Next slide. This is IAB Open. What is IAB Open? Basically, there are 2 points here. One is we want to report out a little bit what we're doing, and the other one is also we want to get feedback from you. If you have any questions that we can't answer today, you can always send us an email. Be aware the IAB email list also has a couple of people who are not the core IAB members. And we have a bunch of other email lists. So we have Architect to Discuss for more discussions. We have Program email list, and we have a separate list for any questions regarding liaison coordination. And that's the agenda for today. Yeah, we basically went through the welcome already. We have an update from Charles about 3GP, just a little bit an overview about the liaison work there. We have the report from the bias workshop that happened in January. We have Stuart here for the thread group, and I think Vivid is online joining us as well. And then we have the invited talk by Vanessa, where we have hopefully a lot of time for questions and interesting discussion. Okay.
All right. So then quickly going through some of the things that the IAB has done recently that you may want to read up on. First, we have some document updates. We have a couple RFCs that have been published since last time. These are both IAB workshop reports. And so you can hear about the environmental impact workshop as well as the M10 workshop on managing encrypted traffic and networks. We also have a document that we have approved for publication that's with the RFC editor on a technical topic about partitioning as an architecture for privacy. And this is looking at the common trend we see across things like MASC and oblivious HTTP, et cetera, as a way to achieve privacy. And we also have a new document, which is the workshop report for bias, and you'll be hearing about that later. IAB also has a couple technical programs, which are kind of open discussion areas. And we have 2 going on right now. We have the EDM program, which is evolvability, deployability, maintainability. This is a program that has produced a couple RFCs previously, and we have one current work item, which is looking at how to better specify and provide advice on how to use greasing and variability in protocols. We don't have any meetings this time around in person, but we will be sending out a doodle soon to schedule a meeting in the next couple months virtually. And so if you're interested in that, please join the mailing list and you can discuss this document there and join our calls. We also have the e-impact program. Suresh, did you want to give a quick update on what's going on there?
Yeah, thanks, Tommy. Yeah, so we did have a virtual inter meeting. So we had a kickoff in Prague, and we had a virtual inter meeting. Yari's also here if you want to have further questions for us. And so we had like kind of 2 teams going through the meeting, and it was like a really nice set of interim meetings, and we identified some short-term work that can start in the IETF. And the ops ADs are in the loop, and they know like this, they can charter some work soon. So probably there might be a BOF in this area at the next meeting. And we will continue to solicit like more topics and kind of keep running this as virtual interims. keeping with the theme of being green. So yeah, thank you very much. And like, please contact us for any questions you have. Thanks.
All right. Thank you, Suresh. All right. So moving on from our programs, one of the things that the IAB does is it also manages the liaison relationships with other SDOs. One notable liaison statement that the IAB issued recently was in response to the Confidential Computing Consortium. We essentially have had a dialogue there about some statements on the use of attestation and the impact on the open internet. So if you're interested in that, please do read that. We also have liaison coordinators, and the personnel here has changed since we have some new folks on the IAB and we're reassigning roles. So now Suresh, Chin, and Miria will be the liaison coordinators. So go to them with any questions about how we want our liaison relationships to work. And of course, we have different liaison managers for all the different SDOs who help work with liaison coordinators to make sure things are running smoothly. And we do have office hours during the lunch slot tomorrow on Thursday. Please come there if you have any questions about liaisons, etc. We don't currently have any upcoming workshops that are planned, but we do have a recent bias workshop, and we'll hear a report on that soon. So with that, I'm going to hand it over to Charles to give us a brief update on how what's happening with our relationship with 3GPP.
Okay. Oh, you got him up already. Okay, great. Hi, everyone. I'm Charles Eckel. I'm the IETF liaison manager to 3GPP. And then on the right-hand side, you have Peter Schmidt. He's my counterpart on the 3GPP side, acts as the liaison manager to IETF. And so just to give you an overview on the IETF 3GPP coordination. Next slide, please. So 3GPP, the focus there is on mobile communications. Hundreds of companies from around the world. It's come together to work on the standards, much like here, contribution-driven and consensus-based. Also, I think it's kind of similar to here, the way it's organized, or the way the technical work is organized. Much like we have areas and then working groups within each of those areas, so 3GPP has these technical specification groups that cover different aspects of the 3GPP architecture. So you have the RAN group, Radio Access Network, you have SA, that's the system architecture, and then you have CT, that's the core and network terminals. So within each of those areas, or TSGs, you have multiple different working groups. And that's where actually the bulk of the technical work gets done. Now then what gets a little bit different from the way we're organized is the TSGs, or the areas, they all meet together 4 times a year at meetings where they're co-located and together. The working groups, on the other hand, they meet in between those meeting cycles, and they can meet once or twice, and they may or may not be co-located with other working groups. So when you're working with, you have liaisons, say you're exchanging back and forth with 3GPP working groups, you need to be a little bit more careful, maybe looking at the schedule and see exactly when they're meeting, when other groups are meeting, because it's not quite as straightforward as what we have here. Let's see, the other thing was, so the TSGs, that's where most of the coordination activity happens. And so when I get later on into the liaisons, you'll see when liaison statements, if you're exchanging liaison statements directly with a working group, you can just talk directly to them. When it involves more than one working group, then that gets coordinated at the TSG level. And so that can impact as well the speed and with which you may be able to exchange that information. Next slide, please. And another thing I thought might be useful, just the way when you look at 3GPP specifications, of course, there's a lot of them, but they all have a specific format. So they start with a couple letters, TS or TR. The TSs, those are the technical specifications, whereas the TRs are technical reports. we're primarily focused on the normative work or the technical specifications. However, it's good to kind of be mindful of what's happening in the technical reports, because even those are informative, they can also often the outcome of that just kind of feeds directly into one of the technical specifications. After those first two letters, then there's 2 digits. That's the series number, kind of gives you an idea of the general area of the standards that you're working with, and then a 3-digit kind of unique ID after that. Next slide, please. So the coordination activities that we have. First of all, we have within the IAB, there's a group created for the coordination activity with 3GPP. We meet at each of these IETF meetings to talk about what's going on there, see if there's anything that we need to address, and just kind of get an update on status. Similarly, at each of those TSG meetings that happens 4 times a year, there is a report on IETF status that's given to 3GPP. So that's kind of the main way in which we coordinate. In addition to that, though, our primary focus is on liaison statements and dependency tracking, and I'll talk a bit about each of those a bit more. The areas in which we seem to have overlap and really need to coordinate, it's mainly around transport and security, and then Yang, both as a modeling language, but also individual Yang models. Next slide, please. So the liaison statements, typically we're exchanging these between IETF working groups and 3GPP working groups. Although, as I mentioned before, if it's something that involves more than one 3GPP working group, it gets coordinated at the TSG level. The way 3GPP meetings work, everything is based on contributions. So there'll be hundreds of contributions for a given meeting. And incoming and outgoing liaisons are just their meeting contributions as well. Just like we have a very specific format for, say, an internet draft, 3GPP has a very specific format for meeting contributions. So when we're exchanging liaisons with them, it's really important that we format them in a specific way so that 3GPP is able to deal with them. And for that reason, if you have some information you want to exchange through a liaison statement, we just request that the working group chairs that they work directly with me and with Peter, and we'll help you just to make sure that the formatting is correct and that we engage the right working groups on the 3GPP side. Next slide, please. And then just an example to kind of run through this a little bit. I won't go into great detail on this, but this was a liaison statement sent from TSVWG to a couple of different 3GPP groups, both the SA3 and RAN3. And very important that we state whether it's for action or informational. In this case, it was for action. And when it is, you need to give a deadline by which that action needs to be done by 3GPP. Then the other really important thing I want to point out is the attachment. And that attachment is going to essentially be the basis of the meeting contribution that I mentioned earlier. Next slide, please. So here we see on the right-hand side that is that attachment, and it's formatted with all the information that 3GPP expects, and with the right headers and that they're looking for. And then on the left-hand side, that's the cover page that actually assigns a unique contribution ID to it. In this case, it was going to SA3, so that's why you see it begins with an S3 and then a document ID number. Next slide, please. So then coming back to us, this was actually the response from SA3 to our liaison statement to them. And so you can see it's coming from SA3, it's sent back to TSVWG, and the purpose here, it's stated as being for informational, and there's an attachment here too, and that attachment is what you see on the right-hand side. And so in the 3GP meeting, this contribution was put together, it was discussed, it was edited, it was revved a few times, and eventually it got agreed, and then that was what was sent to us in response as a response LS. Next slide, please. Now, dependencies. So in addition to the liaison statements, the other main thing we do is look at dependencies. And what these dependencies are is dependencies within 3GPP specifications on IETF documents. So as you can imagine, within a 3GPP spec, there's lots of references to other 3GPP specs, but they also sometimes reference non-3GPP specs, and those could be IATF RFCs, or it could be, in some cases, working group drafts or even individual drafts. Now, the preference there is that it's a published RFC, but in the case it's not, if it's a working group draft or an individual draft, then we track that very closely and try to shepherd it along until it becomes an RFC. Or if, say, it's not going well, it's not going to get adopted by the working group, that we communicate that very clearly with 3GPP, so there's not kind of this false understanding of, oh, hey, IETF's working on this, we can rely on it. And then they find out later on that we're not. So we try to make sure that communication is really clear. And if needed, we'll send an LS back and forth. Otherwise, we can kind of just work and have people work in both 3GPP and IETF and just make sure that goes smoothly. Oh yeah, and I mentioned earlier the TSs and the TRs, the TSs being the normative specifications. That's the only place where we track the dependencies. As soon as a reference to an IETF draft finds its way into one of these TSs, the normative work, that's when we track it. Okay, next slide, please. Okay, and I just want to leave you with a few links on the 3GPP side. This is where you can find out more information about 3GPP, and then also the corresponding links related to this relationship on the IETF side. That's it. I don't know if there's any questions.
Yeah, thanks a lot. So I think actually having these slides is a very useful resource. We also have this for a bunch of other liaisons. So thank you for providing that to us. Yeah, any questions? Yes.
George Michelson, APNIC. There is a conversation going on about erasure of drafts and the potential to have drafts exist in longer lifetimes. It's not that I think it's appropriate for another SDO to refer to a non-published document, but if the concern in reference to draft is that they disappear, there's potential for this conversation about what is the natural fate of a draft. I do think it's better they refer to a published document, but I'm just observing there is a conversation about this.
Okay, yeah.
No, I think the concern is more about they reference something that doesn't have IETF consensus while they believe they reference something that actually is a standardized protocol.
I saw the concern as that it is mutable state and not perpetuating. You're saying it's lack of consensus in the reference.
Well, I'd say it's both, right?
Yeah, different point.
Yep.
Suresh?
Hey, Suresh Krishnan. So, Judge, to your point, right? The 3GPP has some kind of deadline-driven releases. So they have a date by which something needs to get done. So they usually come to us and say, hey, is this draft stable, right? And sometimes they just copy and paste the whole text in just to make that release, but they actually update it to the published RFC at some future point. So that, generally the right things happen because you have a pretty nice coordination relationship between the two. But yeah, that's something because of a timeline.
Yeah, and it's important that once the RFC does get, in the good case where it gets published, then we need to go back and we make sure that we do the right cleanup work on the 3GPP side to actually replace the references to those drafts with references to RFCs.
All right.
Okay, great.
I think
Thanks,
that's
everyone.
it. Thank you so much, Charles. And next, we're going to quickly cover our bias workshop in the report.
Hi, everyone. So we have our workshop report 00 version out. Let me just quickly talk to you about what happened at the workshop. Next slide. The aim of the workshop was looking at, we all agree that internet is such a crucial component in our lives, in our daily infrastructure, as well as how it impacts our society. It impacts the Sustainable Development Goal, SDGs, uphold human rights at a global scale. So in that case, meaningful access to internet and internet services is critical. When we don't have it, it's sort of like a disenfranchisement. And just we have initially focused a lot at connected, the unconnected, and getting but looking next step, what is meaningful internet access, and understanding that was one of our aims of this workshop. And what are the barriers to that meaningful internet access? Next slide. So we asked for reports from the community on what are the barriers in accessing the content and services, understand how internet looks at different parts of the world, understand what being connected is for you, what is the minimum set of requirements for a meaningful internet access. Next slide. It was a 3-day workshop. We did this in January. Each day, 2 hours, an online workshop. The call for papers, we received around 19, of which 12 were found to be in scope and were accepted. We further invited 2 talks, which were very, very timely, that the workshop committee felt led to very good discussion. Overall, around 40 people participated in this workshop, and the workshop committee was Miria, Mallory, Tommy, Chris, and me. Based on all the papers that we received, we divided that into 3 themes: the community networks, the digital divide, and finally, censorship. All the details, including all the papers, the slides, as well as the videos, are available on Data Tracker. So please check it out if this is of interest to you. Next slide. These are all the papers. We want to thank everyone who submitted papers, and this led to a very good discussion. So this slides just basically thanks them. Thank you. So let's start with the 3 themes. The first theme was community networks, which was moderated by me. We all know community networks are self-organized networks, which are another alternative to commercial internet services that we rely on. And in some part of the world, community networks play a very critical role. So the discussion mainly revolved around how do we measure quality of user experience in community networks, looking at various operational and managerial considerations in managing community networks. A very interesting discussion: what is the role of CDNs in this space, which was quite interesting. Again, these days, satellite networks, we know, would play a quite important role in community networks as well. And finally, spectrum. Role of spectrum in this space was also discussed. Thank you. Next step. Next slide, please. So, digital divide. This was moderated by Mallory. It asked what are the disparities in internet access and services, where are the gaps, and what are the different factors that needs to be analyzed in this space. The 3 key aspects that were discussed were looking at various population demographics and seeing how different their experiences on internet was, inequality in multilingual and domains and email addresses, and also the cost of mobile data access, the size of our websites, and what is the correlation. All of this was pretty interesting discussion, but overall we did realize that these covers only very limited set of factors when it comes to digital divide, and this discussion is way broad that can be covered in a 2 hours discussion. Next slide. The final one was censorship. This was moderated by Miria. It looked at how the legal control and suppression of internet access, of mobile apps, of websites, internet shutdowns, how those have been done. We had very good reports on how censorship has been done in some parts of the world, what are the tools being used to do that, and measuring this content, which was quite interesting. The special focus was in 2 places, looking at what's happening at Russia and India. Next slide. I think that will show you some of the ideas of examples of the reports that we got. This was done by Simone, looking at UNI measurements, especially during the Ukraine-Russia war, what was happening with the news websites from Ukraine and how they were blocked, what were the technique used, etc. Next slide. which shows some of the key findings from this report, and the timeline, as well as various different interesting information that was very useful for the workshop participant. Next slide. Another one was from India, looking at 3 different ISPs. What are the different mechanisms they use when online censorship is done in India, and how ununiform it is, how the same blocked content could be visible from one ISPs while not visible from others. Sometimes it's just arbitrary with no legal information available to the person where the content is being blocked. So this was also quite interesting to look at. Next slide. Now focusing on the final set of what were our key takeaways from this workshop. We realized that we need to, as a technical community, there are some management gaps, especially in the community network space. So should we be documenting what are the best practices for running community networks? That could be useful for this. Some of this already exists from various sources, like ISOC does this quite well. But from our technical community, what else guidance that we could provide was one of the suggestions. We also had, should our documents, when they talk about manageability consideration, are they specific consideration looking at community networks, which might be very different from commercial networks? That should be looked at. It should be easy to operate even for folks who are doing community network stuff. With digital divide, the main consensus was that we need to identify what are the few areas where we will have a significant impact, because this problem space is so big, where we will have the most effective and inclusive internet. Those solutions and those key areas we need to focus on. We need to continue to work on enhancing our protocols, that privacy is key, as well as how we can have censorship circumvention tools available, how do we measure them. And this discussion at an IAB workshop is usually the starting point, and this kind of discussion should continue. Some of the pointers that we provided was to our various different research groups. There was, in fact, some early discussion if a very censorship-focused mailing list or a research group could be formed, but these things are pretty early on. And anyway, the aim of the IAB workshop is to bring in a more diverse set of participants and voices in the room, and hopefully that leads to more work in the IETF and IRTF in general. And with that, I'll stop looking for comments from the room. Thank you, and do read the report, give your feedback, and we will be publishing towards the IAB RFC. So thank you.
Yeah, I can also just say I really enjoyed the workshop. I learned a lot. So I recommend you to look at the report, the slides, continue the discussion. Go ahead.
Hello. I haven't read the report, but if I go and look at it, will it? So the question in my mind is, what does a community network look like? Because I'm not in one, so I just wanted to understand better what that means. So is that described in the report, or can you point me somewhere that?
It points to the right RFC where you can learn about it.
Perfect.
It's in fact
Okay.
in Gaia research group, they have a very good document that talks about what is a community network, what is this, and that's being referenced. So you can find some resources there already.
Great, thank you.
Right. Hello. Yeah. Hi, Arnaud Tadei, Broadcom. So just to provide feedback. So when the workshop was announced, as you remember, I was very skeptical. Right. I procrastinated to death. I finally made the contribution. It was not accepted, but you granted me the invitation to participate, and I was very happily surprised. It was good. I was very happy to see a format of a workshop. I think the conversation was great. I learned a lot. There were many learnings in this story. Few things that I noticed that I'm sorry, I didn't have time yet to review the report. It was just impossible so far, but I will. There are 3 points that I would like to bring here. I think the first one was the fact that when we discussed during the workshop we realized the problem to support better, for example, the community network, we are missing a population in the IETF. Right? So we have a problem of how we reattract people in the IETF that could then better help to create best practices, because there was a request for more operational help. And there are not enough operational people here. That was one thing that I don't know if it has been properly documented in the report, but that will be my feedback to the report. If not, that's okay. The second is that I don't know how many times we had a discussion at nearly every single presentation on the term cybersecurity. Right? So I know that, Dhruv, you made it right. On your slide for the second one, there were plenty of technical issues. I remember this because this is a passion for me, but you represented that correctly, but it's just I was surprised how much time it came. I wonder if we should not have a second look at this one from that perspective. The third one was a shock. The shock in the censorship was when I think Mona explained the study that was remarkable on how she measured and she figured out that there were some commercial enterprise class proxies used to do censorship. And I could find a list of my competitors there. And I was absolutely ashamed. Could not believe it. Even technically, I could not believe that this could even be possible. So I followed up with Mona and we discussed that. I figured out that there are simple things that the vendors could do to avoid this situation. And this is a follow-up maybe we should have on that, because there are people who are in this room. I would be ashamed if I would see the name of my company in this list. That's it. Thank you very much.
Yeah, thank you. A very good point. A lot of commercial systems are used, have all these filtering techniques and whatever, and these are the same techniques that are actually used for censorship. Yeah. Maybe something we should add to the report. Yeah.
Hi, Andrew Campling. In this context, a trustee for the Internet Watch Foundation. I just thought it was worth saying that given the definition of censorship is sort of the legally mandated blocking of content, clearly there is some content that I hope most of us, at least in this room, would be quite comfortable is legally blocked. And I just feel slightly uncomfortable that if we look at techniques to bypass censorship, we may actually be facilitating the sort of further explosion of access to, for example, child sex abuse material by bypassing controls which are there for a purpose to sort of stop that sort of exploitation and protect the human rights of children. So, whilst censorship can be a problem, I think definitions here matter, and the definition on the slide is extremely broad, in my view.
Yeah, so we have not sure you had a real question or
it was just to say that as framed, I've got concerns that we're going down a difficult path as a community that will cause problems that we wouldn't want to be take responsibility for.
So, and this is not part of the workshop, but there is an RFC, which is a research group RFC that actually defines censorship very broadly. So that discussion happened already. But what we also recognize at the workshop is that I think we need more discussion in this space. So it's ongoing, and there are a lot of things. There are also a lot of things we all need to learn about what's going on in the world. So I'm very much interested to continue that discussion. Yes.
Thank you, everyone. Do read the report.
Thank you, Drew. All right, Stuart. I can do the slides for you.
Right. Thank you, Tommy. Miriam, in conversations in the past, I realized that a lot of people at the IETF had never heard of Thread. And it's something I've been working on for a few years now. And in talking with the IAB members, we thought this would be an interesting thing to bring to the IETF. So I'm going to cover 5 main areas today. You can see the list on the slide here. Let's move on. So quick overview, Thread is a wireless networking technology. It's designed to be very low power. I have some magnetic door and window sensors made by Eve. They run off a half-size AA battery. And I think Eve claims a year battery life. In my experience, I get close to 2. And if you're running those things with Wi-Fi, you'd be changing the battery every week. The hardware is really cheap. You can buy developer kits in quantities of 1 for around $10 and probably much less than that in volume if you're building it into products. The data rate is 1/4 megabit per second, so it's much slower than Wi-Fi, and that accounts for its much lower power consumption. After you take the overheads into account, maybe 100 kilobits per second useful throughput, and if you're going multiple hops through the mesh, maybe 30 kilobits per second. The range is about 30 meters, and Thread was designed from the start with close attention to security. So the cost, the range, the power consumption, and the performance here is very similar to Bluetooth Low Energy or Zigbee, and indeed Thread uses the same IEEE 802.15.4 hardware that Zigbee uses. The difference is that Thread from the start fully embraces IP, whereas some of these other technologies are designed to be completely separate, barely even acknowledging that IP exists. This is the overall architecture. At the hardware layer, we have IEEE 802.15.4 radios that send 128-byte frames. They operate in the same 2.4 gigahertz unlicensed band that Bluetooth and Wi-Fi use. This is nice for product vendors because you can make a single product and sell it worldwide. You don't have to build different versions for different countries. On top of that, we run IPv6 using 6LoWPAN, and the part the Thread group adds is a self-configuring, self-healing mesh, because 6LoWPAN is a point-to-point one-hop framing. It defines how you encapsulate V6 packets over the 15.4 radios. What Thread adds is to put multiple of these together to make a mesh. What's interesting about that is many of us today using Wi-Fi end up buying range extenders or similar technology because we want good Wi-Fi coverage everywhere in the house. Because all powered Thread devices act as IPv6 routers, they forward packets on behalf of other devices. So the more Thread devices you add to your house, you're not overloading your network the way you might with Wi-Fi. Actually, the more Thread devices you add, the more you strengthen the network and the more redundant paths you create and the better coverage you create over the whole house. So Thread creates a mesh. There's a key technology, which is that mesh is not a lot of use if you can't communicate with it. So Thread has a device called a Thread border router, which you can think of as being somewhat analogous to a Wi-Fi access point, but there are some differences. If we just bridged Wi-Fi and Ethernet onto Thread, even a modest amount of multicast traffic on your gigabit Ethernet would be more than enough to completely flood the Thread mesh and it would stop working. So whereas with Wi-Fi, the packet formats are similar, the MTU of 1500 bytes is compatible, the 14-byte Ethernet header is the same. You can bridge Ethernet and Wi-Fi together, and that works really well. That would be a complete disaster with Thread. So we looked at this and decided that IPv6 had a lot of benefits here. And the IETF has been working on IPv6 for a long time. Adoption has gone fairly slowly. But we didn't approach this as some kind of religious dogma that we want to do v6 just because. We looked at the capabilities that IPv6 provides that aren't there in other protocols and weren't there in IPv4. And we were able to build a routed home network instead of a bridged home network. And it was really important to do that in a zero configuration way, because the average residential customer buying these devices does not come to IETF meetings, and we don't want them to have to configure anything manually. So the underlying principles here are, we made use of IPv6 router advertisements. So when you buy one of these devices, which has thread border router functionality, it does these things automatically. And a thread border router is typically not something you buy as a dedicated device like you might buy a Wi-Fi access point. It's functionality built into other products that a lot of people already have. If you're looking at automating your home with smart thermostats and light switches and things, then it's probably the kind of household where you may have a smart speaker or something like that. So the thread border router functionality is built into the Apple HomePods, Apple TV, it's in the Google Home Hub Max, it's in Amazon Alexa, I'm probably forgetting other ones. So many people, just in the course of buying products they would buy anyway, get this border router functionality as a side effect. And most customers don't even know they have it. It's just something there that works when they need it. And in order to do the V6 routing, our first choice is DHCP V6 prefix delegation, where your ISP gives you full global V6 service. They give you a /56. Your home gateway can then subdivide that and allocate /64s to networks within your house that need it. That's great when it works, but we also need a fallback for when it doesn't. And the short summary of that is, if your smart speaker finds there are no IPv6 router advertisements on the network, then it will step in and take on that role itself. It will pick a couple of random ULAs, one to assign for the thread mesh, one to assign to your Wi-Fi or Ethernet network. It will emit IPv6 prefix information options, PIO, on the Wi-Fi network, saying, all you devices here, here's a prefix that is on link for this network. So you can now assign yourself a V6 address that's larger scope than the link local you already have. And it does the equivalent on the thread side, and it publishes route information options telling all the devices on the Wi-Fi network, if you want to reach a destination in this prefix on the thread network, I'm your router for that. So don't send it to the default gateway, don't send it to your home gateway provided by the ISP. Send those packets to me because I know how to forward them. All of this framework was defined in IPv6, and we're able to make use of it. And then the other thing that Thread offers is commissioning, because in the early days of Wi-Fi, you would type in the password on the screen on the device, but light bulbs and light switches and things often don't have a screen. So Thread also, from the start, has mechanisms for doing that commissioning in a secure and trustworthy way. So Thread is an IPv6 link layer. And in principle, it will work with anything that uses IPv6, which is, of course, why all of us here are so enthusiastic about the internet, because it has all this flexibility. You probably wouldn't want to stream music or video over Thread. The data rate isn't high, but modulo that data rate limitation, anything that works over IPv6 will transparently run over Thread, and the application doesn't even need to know any difference. So Apple used this for HomeKit a few years ago. There's a new industry effort called Matter, which I expect a lot of people have heard of from CSA, the Connectivity Standards Alliance. Matter is a home automation protocol. Unlike Zigbee and Z-Wave and things like that, Matter fully embraces IP. The previous code name for Matter was CHIP, Connected Home over IP. So it's got IP right there in the name. And because of that, you can run Matter over Ethernet, you can run it over Wi-Fi, and you stick a Thread network in, you can run it over Thread unchanged. Other industry groups in the commercial building automation space, like DALI, which does lighting, these lights here may well be DALI, They use Thread for their wireless IP control. And part of the reason that we're talking about this today is many of you in the room may have ideas of things that run over IP that would work really well over low cost, very power efficient wireless IP technology.
Come on.
Doesn't work.
There we go.
So a bit of information about the Thread Group. It is a membership-based industry alliance, a bit like Bluetooth or Zigbee, kind of modeled on that. I want to give a shout out to my colleagues here. Vivid Siddhar from Apple is president of the Thread Group. He's not here in Brisbane, but he is connected online on Meet Echo, so he's available to answer questions. I also want to acknowledge the many, many years of hard work done by Jonathan Hui from Google, who is our VP of Technology. He is really the brains and the architect behind a lot of this. In fact, you'll see Jonathan's name as author on the RFCs for things like 6LoWPAN, and that's not a coincidence. Jonathan can't be here because CSA is having their meeting in Singapore the same week as IETF. So Jonathan, I think, is called in on Meet Echo from Singapore right now. But I wanted to acknowledge that I'm here telling you about this, but really it's the work of Vivid and Jonathan and many, many other people. If you look on the Thread Group website there, I don't want to be missing anybody out, but there are many people who've worked hard on this. As a membership industry association, Thread is a bit different from IETF. Thread has three main activities: technical, certification, because after the specs are made, unlike the IETF, Thread runs a certification program to verify that products comply with the specs. And to use the Thread logo on your products, you have to pass the certification test. Thread also has a marketing committee that helps companies promote and sell their products. But from the IETF perspective, it's the technical that is most interesting. And many of the things we develop in Thread are done internally in the Thread Technical Committee, but there are some things where we look at it and we think, this is useful for Thread, but it has broader applicability than that. And for those, we bring those to the IETF, and I'll give a couple of examples. Service registration protocol is work done in the DNS-SD working group, which is the evolution of multicast DNS from 20 years ago. And I mentioned before that just bridging Thread and Ethernet together would not work because of the huge mismatch in data rates. So we don't want to do service discovery by just taking all the multicast off the Ethernet and the Wi-Fi and flooding that onto the Thread mesh. So because of that, we've built a unicast-based discovery mechanism, which has the same semantics. If you look in the packets, they're very similar, and the naming and the syntax is very similar. But instead of flooding multicast to everybody, devices offering services register with a service registry using a unicast registration, and devices that want to query send unicast queries to that registry. And then once they're subscribed, they get continuous change notifications as things come and go that they're interested in. That is work that's going on in the IETF. Related work led by Ted Lemon is stub network auto configuration, because I described this border router, which we need for Thread, and Matter is using it. But this concept of a self-configuring routed IPv6 network has applicability beyond just the Thread radio hardware. So for these things, we thought it was useful to bring that to the IETF, and that is really a win-win situation. The engineers working on this, like Jonathan, me, and Ted and others, we get the benefit of all the wisdom of the IETF. And then when the technology is done, it can be shared freely with other groups that have similar needs instead of being a proprietary thing developed and managed by the Thread group. And then my last preview here is I am planning to set up an event at the next hackathon in Vancouver, where we'd love people to come along with their ideas. We can give you hands-on help with the developer tools. This picture here is a little thread board, one of the ones I told you that cost $10. It plugs in the USB port on your computer, and you can see from the scale of it that's the USB plug at the end. So this is a really tiny thing. And right now, the way these developer kits work is you flash the firmware over the USB port, and there's a command line interface for OpenThread where you type commands over a serial port. One of my personal projects I'd like to get done is to port SSHD to run on OpenThread, because as a network device, you shouldn't have to plug it into your USB port to interact with it. You should be able to connect over the network with SSH. So we're starting the work now to set that up for hackathon. Anybody who's interested, let us know, and we'll all sit around a table and have fun hacking in 4 months' time. And with that, I'm ready for questions.
Yeah, thanks a lot. So it's really nice to see this. We brought you here because we were all impressed, like how the work we're doing here is actually used and come together and make sense. So that's why we invited you here as well. Any questions? I guess there was a little bit of a question from George, and you can come to the mic if you want. He was complaining that his IKEA devices don't use Thread yet or something like that.
Sorry, I was George Michelson, APNIC. I was doing pointless back chatter on.
Yes. No, but I guess the
Meetecho.
question here really is about deployment.
But there is a qualitative question there. I mean, it's kind of the thing you probably can't answer. Is this going to become market dominant behavior? Because the proliferation of semi-proprietary, vertically siloed approaches to smart devices is enormously painful. And I would like to be able to walk into IKEA, buy a light bulb, buy direct off Amazon a Philips product, buy an intermediary device in the home, and have them bootstrap into some sense. There is a kind of ancillary thing, which is that I have a loathing of third-party rendezvous in the cloud. And I would really hope that Babel, given names like Ted Lemon on that list, people with experience of HomeNet and Babel would be constructing systems that do not demand out-of-home rendezvous to work.
Yes, I can only speak here for myself, and I 100% agree with you. I have advocated very strongly for the same things that you're saying, that Matter is peer-to-peer within the home, and for privacy reasons, if you can avoid information leaving your home, then that's preferable. Cloud-based services are still possible if companies want to do that. But as far as the Matter specification goes, it doesn't require any of that. So my personal mission here, and this is why I've spent so much time working on Thread, is I'm a big believer in IP. I'm a big believer in generic technologies. So at times, various people have said Thread should become part of some other industry group. And I've always resisted that because I want Thread to be like Ethernet and Wi-Fi. Ethernet is not the technology for printers, say. It's the technology for whatever you want to use it for. So I have been working hard to maintain the independence of Thread and work with any individuals, hobbyists, companies, industry bodies. Anybody who wants to use it is equally welcome. And obviously, I'm standing here in this room, and I've been working in the IETF for a long time. I'm a big believer in IP as the demultiplexing point, that if you want to write an app, build it on IP, and if you want to build some hardware, make it support IP, and that becomes the universal crossbar switch where any app, any hardware, you can put it together as suits your needs.
Yeah, and then because Vivid joined us online, I wanted to check if you want to have some last words here. So if you want, just enable video and audio. I'm not sure what time zone it is where you are. So.
In California, I think it's 8:30 at night right now, so it's not desperately bad, but it is evening.
Yeah. Okay, but there's also more in the chat, and you can ask questions to Stuart. Thank you very much.
Yeah, I'll be here at the end if anybody wants to come and talk. Thank you.
All right, thank you very much. And now we move on to our last talk, which is our invited talk from Vanessa. see if this works.
You just have to tell us. Is it all right with you if I fill? Because I like to go forwards and backwards sometimes.
We don't have a clicker at the moment.
Yeah, I don't have.
Do you want to plug in the
I
clicker?
can try. Are these working? Are
Okay,
they
yeah,
working?
should be.
Okay, let me see if I can get it.
That's just some of the slides are a bit
Mhm.
detailed. And,
Oh boy.
Yeah.
Yeah. Not sure it's working.
Don't know if it's working. Do you want to try it from you? Also, if you have a phone, you could run it from your own. You want to?
Can go from my phone.
Yes. Do you want to do that? 1 second.
Can you hand it over to me directly or request it?
You can request it.
Like this?
Try it again. Yes.
Thank you. It will actually make the talk a lot better.
Yeah, of course.
All right. Hi, everyone. My name is Vanessa Teague. I'm a cryptographer by training, and today's talk is about techniques for detecting known illegal material in end-to-end encrypted communications. So this is not original work by me. This is an opinionated survey of stuff that's already out there. The survey is joint work with Shannon Coney, and it's also very heavily influenced by the co-authors of Bugs in Our Pockets, The Risks of Client-Side Scanning. So I'm going to talk a little bit about the Australian context for the international audience that's here. I'm going to talk a little bit about perceptual hashing and the cryptographic private set intersection protocols that are proposed to be used for this detection. I'm going to explain my concerns and describe some possible attacks, and then some efforts to mitigate those attacks.
Can you go a little bit closer to the mic or just take a photo,
Closer to the
whatever you
mic. How's this? Is this better?
want? Turn it down a little bit, yeah.
How's that?
Great.
Yeah, person with the thumbs up in the back, please give me more of a signal if you can't hear me again. Awesome. Okay, so here's the Australian context. These are the draft online safety industry standards that our e-safety commissioner has recently released. So this is not a bill before the parliament. There's no committee process or other way of examining them. This is a draft standard that... Is it hard to read because of the fine print? Not from there. I'll read it out aloud. Okay, detecting and removing known child sexual abuse material. The provider of the service must implement systems, processes, and technologies that detect and identify known child sex abuse material. And then the end says, subsection 2 does not require a provider to use a system, process, or technology if it is not technically feasible for the provider to do so. So what this envisages, I think, is that there is some kind of trusted list of short summaries of known offensive or illegal images, and that providers are required to check whether or not the users of their system are sending any images or other kinds of data that match a predetermined list. And interestingly enough, you get to not do it if it's not technically feasible, which strikes me as weird because I can't see any reason it would not be technically feasible, right? Just turn off encryption and hash the plain text and we're done. Okay, so next, the next section, or the next section plus one, which I have to say I just don't understand, is the following. It says, disrupting and deterring child sexual abuse material and pro-terror material. I've skipped a section that was basically the same as section 20, which applied to terrorism material as well. Now, note that this doesn't mention detection. So there's no requirement here that any conclusion gets exported back to the service provider. This is just, I think, this is just talking about on-device identification. And it says the provider of the service must implement systems, processes, and technologies that effectively deter end users of the service and effectively disrupt attempts by end users to use the service for various various illegal activities, including child sex abuse and terrorism. Now, the interesting thing about this, so first of all, the word known is not present. So we're not talking about just matching with a list of known illegal materials. We're talking about examining new materials and somehow making a judgment about whether they fall into one of these categories or not. Secondly, there's no out for technical infeasibility, which I find bizarre because this strikes me as an extremely challenging technical problem, right? It seems to me to be envisaging running an AI on the device that is making a judgment about whether a particular new piece of text or image is in one of these illegal categories. So for the purposes of this talk, I'm going to ignore this requirement because I don't really understand it and I don't see how it's going to be enforced. I'm just going to talk about technical proposals for identifying known illegal materials. I think everybody knows what end-to-end encryption is about, but we have a little slide in the talk. Does anybody not know what end-to-end encryption is?
Yes.
Excellent. End-to-end encryption, Alice and Bob have a key, the service provider doesn't have the key, the service provider isn't supposed to be able to read Alice and Bob's messages. If you think about it hard, which you probably already have, you'll realize that there is a whole lot of contextual support that is necessary for actually getting the security goals you want. For example, Alice and Bob has to authenticate each other properly to make sure that the other end of the communication really is the end that they think it is. Don't bother using Signal with your friends if you haven't verified your conversation number, because then you don't actually really know whether you're talking to them or not. Similarly, if it's a group end-to-end encrypted chat, you need to be sure that you know who's in the group. And in fact, some famous proposals for breaking end-to-end encryption have been presented as, we're not breaking the end-to-end encryption, we're just quietly adding a new person to the group. What's the problem? So it's not quite as simple as Alice and Bob having the key and the service provider not having the key. There's significant contextual support that is necessary for really getting the security guarantees. And obviously, not end-to-end encryption is not that. It's odd that this is now the norm, so we don't have a name for what this is, whereas really the previous thing ought to be the norm, but this kind of server-mediated version of encrypted communication has become the norm. So Alice has a key which she shares with the service provider. She thinks she's talking to Bob, but actually, as far as the crypto is concerned, she's talking to the service provider and hoping that the service provider forwards the message to Bob. Okay. Does anybody not know what perceptual hashing is? Quite a few people. Okay. I didn't either until I started looking at this. So this extremely fine print really makes it very clear. The goal of perceptual hashing is to mimic the human visual system's assessment of comparing two images based on the underlying scene content. There you go, now everybody knows what it is. So the idea is we're going to take some kind of content, maybe it's a picture, maybe it's a video, and we're going to compute. Unfortunately, the word hash is used, but it's not in any way similar to a cryptographic hash function. It's in fact, it has almost the opposite desired properties. The aim is that we get a string that somehow describes what this piece of data appears like to a human. And it's supposed to have the property that very similar pictures, for example, will have very similar hashes. And even that small kind of photo editing processes like changing the color or scaling it slightly are not supposed to change the hash at all. I've never found a precise definition, but this is meant to be the intuition. So examples, Meta has one, it's called PDQ, Apple's neural hash, Microsoft's PhotoDNA, there's quite a lot of public domain ones that are available. Meta's is open, there's a GitHub repository with some reference implementations. Neural hash and PhotoDNA are supposedly secret, but it's not hard to find a copy on the internet. So we could ask the obvious two questions. If the idea is that perceptual hash functions are going to be used to identify known illegal materials, well then there's two obvious directions to ask about what somebody might do to attack such a system. The first attack is evasion, obviously. Suppose that somebody wants to share an image that they suspect is on the list of forbidden materials. So they want to share something that looks like the image, but they want to modify the image in such a way that the hash will be different. This obviously isn't supposed to happen, but various works, of which this is the most recent example, show that in an adversarial context, it's really not very hard, even just with black box access to the implementation of the perceptual hash function. So evasion, in the sense of trying to make a picture that really looks very similar, but actually has a completely different perceptual hash, seems to be easy, at least for researchers. And I should also say that maybe it's obvious, but it's not obvious enough to really get into the public discussion about this stuff, that just kind of not participating is also an obvious kind of evasion, right? Zipping the photo, or cutting the photo into 4 different photos, or XORing it with some other thing that the person on the other end has, on the assumption that the person sending the photo has some kind of control over their device. These kinds of evasions are going to defeat perceptual hash-based detection. Okay, so that's one direction, if you like, of attack, trying to make an image that looks the same but has a different hash. And now the obvious dual attack is, okay, let's try to make 2 images that look different but have the same hash. Now, for a cryptographic hash function, remember, this is supposed to be extremely hard. And we believe, at least I believe, that with something like SHA-256, it's very, very hard to get 2 different things that make the same hash. For perceptual hash functions, it doesn't have that security property, right? And it's interesting that it is often assumed in the broader public discussion that it kind of sort of has that property, but it does not. And so there's extensive research, of which these 2 examples are the most recent and comprehensive, that looks both at accidental collisions in large databases of images and also at deliberate manipulations of images that can cause images to have the same hash, even when the images look very different to a human. So if you can't read the fine print, but you can see the picture, on the left, we have a photo of a political protest. And the assumption is, this is something that somebody wants to send without being detected. On the right, we have a target image, which is a cute photo of a puppy dog in front of a Christmas tree. And we're concerned that, hang on, let me explain the attack. Never mind, I'll explain the attack in subsequent slides. Let's just talk about the technical fact, right? So the technical fact is I've got a target image that has a particular hash, and I've got another starting image on the left, and I want to manipulate the starting image so that it looks similar to a human, but it has the hash that matches the target image on the right, not the hash that matches the original image that I started with. And so this figure, which is copied from Lucas Strupek et al., shows a very general algorithm for achieving these kinds of clashes. And again, both of these works only have black box access to the hashing function. They're not looking at the details of how the hash function works and deliberately creating these examples. They're just kind of running some algorithms that try the hash, move it a little bit, try it again, and so forth. Okay, so that's perceptual hashing. Now we want to talk a little bit about the cryptographic proposals that have been designed to be built on top of perceptual hashing to add some security properties to the matching protocols. So private set intersection has been a thing in the cryptographic literature for many years, long before this particular application occurred to anybody. These protocols are really cool if you like this sort of thing, which I do. And they're the kind of nifty crypto that seems almost magical unless you're accustomed to looking at the mathematical details. So the setting is something like this, although there are lots of different flavors in the literature. Suppose Alice starts off thinking of a set of numbers. Bob starts off thinking of a set of numbers. We want Bob to learn the intersection of the 2 sets. In other words, the set of things that are common to both of their inputs and nothing else. And we want Alice to learn nothing. Sometimes we let Bob learn just the size of the intersection. Sometimes we say it's okay if we leak a bit of information about the size of each other's inputs. But this is the basic idea. We have two people, they both start off with some input data. One of those people is going to learn about the intersection of that input data and nothing else. So this is cool and very clever. Oh, actually, I might show the picture first. This is what I wanted to flick through my slides. So how would private set intersection fit into a proposal for detection of known illegal images? The picture would look something like this. Assume that we have some kind of trusted source of the perceptual hashes of known illegal material. So on the left, somebody like the National Centre for Missing and Exploited Children or the police or somebody is going to supply the service providers with a list of perceptual hashes of forbidden items. The user device is going to have an implementation of the same perceptual hash function. So when they're about to send a picture or something, they're going to apply that perceptual hash function. That's going to give them a set of numbers. And then the service provider and the user are supposed to engage in a private set intersection protocol in which the service provider learns how many or which or something, learns about the intersection between what was on the user's device and what was in the list of known illegal materials. So there's a lot of really interesting, really clever literature in this space, of which probably the most famous is the Apple private set intersection by Baumick and Bonnet and others. There's also another paper that came out about the same time by Ananai Kulshrestha and Jonathan Mayer at Princeton. They both have similar but slightly different privacy properties. So Kulshrestha and Mayer are envisaging a single item from the user being matched against a whole list from the provider. They have an exact version where they match, where they detect whether exactly that hash is present in the list. And they have an approximate version where they check whether the client's hash is within some Hamming distance of something on the list. And that's because, remember that even though perceptual hash functions are not supposed to be subject to small modifications like scaling or rotating, in practice they actually are. So there's a motivation for testing for slight differences between the client's hash and the hash in the list of forbidden items. The Apple proposal has a different set of privacy goals, of which the most interesting is the idea of a threshold function. So they have a sort of a baseline version that just reveals the intersection, but they have a threshold version in which if the size of the intersection is below a certain threshold, the server only learns the size of the threshold and doesn't learn anything else. Whereas if the size of the intersection is above that threshold, the server learns the data that intersected. In other words, the pictures that are supposedly on the list of illegal images. There's also a fuzzy version where the exact size of the intersection is a bit obfuscated. So these are very clever, right? These are highly sophisticated, provably secure protocols by people who really know what they're doing. And there are very nice proofs of security. There are analyses that show that the rate of false positives is incredibly low. So what's my concern? Well, in a nutshell, the private set intersection protocol has very strong security properties. The input data doesn't. So my concern is that the proposal is to run a very sophisticated, highly secure protocol on data that I don't see any way of relying upon. There's actually a very strong analogy with internet voting, which is my other favorite topic. You might think that the fancy cryptographic verification step in the middle was the hard step, but actually, and maybe you already know this because this is what you do, but actually like the interfacing of the inputs with the real world is the hard step. Okay, so let's just overview some concerns and attacks. In no way is this meant to be comprehensive. A little bit more Australian context for those who are just visiting. In 2019, the Australian Broadcasting Commission, which is sort of our version, our knockoff of the BBC, published a series of articles detailing allegations of war crimes by Australian forces in Afghanistan. The Australian Federal Police raided the ABC, and although initially there was talk of charges against the journalists, what they were really looking for was identifying a whistleblower. The drop in question included both text, like documents, and images. So my question is, how could we make sure that an image like this, which is illegal, was not actually part of the database of illegal images that everybody was matching against? Oh, sorry. In short, I think the answer is we can't. And I can see at least 3 different ways in which there are very plausible scenarios for which data that does not in fact exclusively cover terrorism or child sex abuse material might end up in the list of known child sex abuse or known terrorism hashes. Here are 3 examples. So one example is just that the trusted sources might accidentally add wrong images to the list. And if you think that sounds unlikely, remember that these are huge databases full of the kind of material that no sane person enjoys looking at. And we have at least one documented case in which the Irish police reported in response to a Freedom of Information request from the Irish Council for Civil Liberties that about 10% of the images they received from the US National Centre for Missing and Exploited Children were not actually child abuse material. And they cited, for example, adult images and kids playing at the beach and things like that. There's no suggestion that these inappropriately categorised materials were deliberately added into the database. It's just it's a big database, they get all kinds of reports and their curation isn't perfect. The second possibility is, as I alluded to a few slides ago, the possibility that Australian law enforcement might deliberately add images that are illegal, including, for example, whistleblowing about war crimes, but which are not on the list of things that the e-Safety Commissioner is talking about when she's talking about imposing these rules. And the third possibility is that external attackers might use the clash properties of perceptual hash functions to get things into the database that were not actually things the Australian authorities intended to include. And so this is the attack that I explained badly when we were looking at the picture of the puppy dog in the protest. But the attack would go something like this. Imagine that a malicious party wants to figure out which Australians are sharing photographs of Tank Man. So they use the clash properties of the perceptual hash function to generate let's say, an image of glorifying terrorism or something that is illegal in Australia that has the same perceptual hash as Tank Man. They make sure that this offensive image comes to the attention of the Australian authorities, who, with the best of intentions, load it into their database of forbidden images. And now everybody who shares a photo of Tank Man gets flagged. So I am not in any way the first person to identify these kinds of issues, and the proponents of these systems have a number of attempts at defence. One is, in fact, Apple, when they first introduced their private set intersection system, said that they'd have a sort of secondary check by a human before there was any kind of automated detection to the police. But that actually doesn't solve the problem. It actually doesn't solve any of these problems, really. If, for example, the image is a sexually explicit consensual image that 2 people thought they were sending to each other, the fact that a committee of people at the service provider inspects it before they hand it on to the police is not comforting. If the Australian law enforcement authorities deliberately added it to the list because it is illegal in Australia, then the committee may be obliged to report it, even if it wasn't one of the categories that they thought the system was going to be used for. And if a genuinely malevolent external party has attacked it in the way I described in the third slide, then there's a risk that they've infiltrated that secondary process. And there are already documented cases, for example, of agents of the Saudi government infiltrating Twitter in order to expose information about Saudi dissidents who were anonymously posting on Twitter. So I don't really see a good solution, a good procedural solution to address any of these concerns. There are some transparency efforts from the research literature that derive from the sort of cryptographic traditions of transparent and verifiable kind of computation to give, for example, to prove that everybody is being compared against the same list of hashes, to give people the opportunity to verify that certain things are not in the log, and various other clever kind of crypto things. There's a couple of good examples here, but both of these works, despite being interesting and clever, make it very clear that they're not a complete solution to any of these problems, and that, for example, they don't really solve the whistleblower detection problem because you kind of have to know what you're looking for. It's very hard to prove the absence of anything within a certain Hamming distance of a given hash. And all in all, although they're interesting, they really don't solve the problem. So that's my second last slide. So in summary, if you happen to be living in a country where ubiquitous, warrantless scanning of everybody's devices, just in case they turn out to be a terrorist or a pedophile, is accepted, which apparently I do, there remain very strong, very serious technical concerns about how that could be implemented in a way that is just and transparent and accurate. And that's the end. Questions welcome.
All right, we have a queue starting. So Wes, kick us off.
Thanks very much, Wes Hardiker, ISI. Fascinating, problem, and certainly one that is being well thought about in many venues right now, and with many concerns. A couple of thoughts occurred to me. I guess I'll stick with one. Images are great. With the advent of video and 3D worlds and everything else, it seems like they're obsolete at this point practically, let alone frames within a video, let alone, pictures pixelated onto the side of a 3D triangular set of objects and things like that. I assume that the lawmakers and the technologists have not even come close to being able to catch up to that type of hashing, or whatever terminology you want to use. Do you have any thoughts, or have you seen much in that regard?
So there are perceptual hash functions on videos. I've never looked at them carefully, and I don't know whether there are research papers on the same kinds of attacks, but I assume it wouldn't be any harder than they would be for images.
Well, I guess I would bring to the next question: what's the computational feasibility of doing movies or larger data objects? I mean, the problem is that there's a difference between recorded videos of a particular length where you can analyze the entire contents of the file in an entire pass versus I'm panning a camera around, right?
Yeah, I agree. If anything, it seems even harder to get right with videos, and it's not right with images.
Real time becomes a real problem.
As we don't have anybody in the queue, but we had a lot of discussion in the chat, I would actually like to call out Ori and he's not listening. He is, because he moved your attack and to another level with AI. So you want to maybe explain that and start the discussion here?
Hello, I'm Ori Steele. So I work on supply chain security and transparency here at the IETF, and our focus in the SCIT working group is on software supply chain transparency, but we interact with all aspects of the software ecosystem, including provenance for artificial intelligence models and content derived from artificial intelligence models. So I left a comment in the chat sort of basically saying, these days you can ask an AI to generate you interesting content that's very finely tuned, both with text or with, control net and other techniques. And if you've got, an implementation of one of these perceptual hash functions sitting around, you can kind of set those two things next to each other and just ask for an image that hits the hash over and over again until you get one. Probably take you like very short period of time to set that up if you wanted to. So it doesn't seem like a particularly good system.
Yeah, I agree.
All right, Brian.
So yeah, I'll actually, hello, thank you for the talk. That was awesome. Standing ovation in my room at 5 in the morning. The question that I put into the chat that I decided to come and call myself out on is, how many of the sort of like false or like incorrectly tagged images in some of these databases would you think are evidence that there are already pre-image attacks occurring in these databases?
Oh, as far as I know, none, which doesn't mean they're not occurring. So the specific example that I mentioned, the Irish example, the police were quite coy about exactly what it was, but those two examples that I mentioned were the two examples that they said. They said adult content and kids playing at the beach. They didn't say that that was comprehensive. So the assumption is that there's no indication that any of the stuff that was wrongly categorized was deliberately so. There is quite a lot of work about, there's quite a few papers that look at accidental collisions of perceptual hash functions in very large databases. And again, all of the examples that I know of are things that are kind of plausible and accidental. For example, things that really look the same, like a big photo of one kind of big long black stick on a white background and some different person who took another photo of a different big black stick on a white background kind of thing. So I don't know of any evidence that any of these attacks are being deliberately performed by anybody other than researchers raising awareness, but that doesn't mean they're not being performed.
Would there be any way to easily detect that?
No,
I mean,
only
there's
if
the
you,
obvious ways, but
yeah, only if you somehow came across both images, right?
right.
So unless
Okay.
the people performing the attacks were making their clashes evident, which the researchers are, how would you even know that they were doing it?
Cool. Thank you very much.
Good question, though.
Martin Thompson. I just want to draw people's attention to analogues with what Vanessa's talking about here and some of the things that are going on in adjacent areas. So there's a lot of focus right now on provenance for AI generated content. And one of the methods that's often touted as being excellent is kind of a reverse perceptual hash in a way, whereby you have an image and you apply tweaks to that image such that it produces a watermark. And you have another system that detects the presence of that watermark, and through any types of manipulations, the watermark is supposedly preserved. And again, there is a long list of material that basically describes, well, if you've got a model that applies the watermark and a model that detects it, you can put a model in between that removes it and another one that puts a different one in. Yeah. And it turns out these are really very difficult problems, and it's quite possible that there are no good solutions. And in fact, I think I've seen people claim that in some of these papers.
Yeah.
Yeah, but and so at this point, I would like to just rephrase your point, which is like we talk so much about the cryptography, but the problem is also the transparency and like how this data is sourced, right? And that's something that is even harder, and we don't talk too much about it, or not enough about it.
Yeah, I agree with that very much, actually. In some ways, it's more the transparency that's actually, and in the context of law enforcement, right, transparency is a huge deal. Transparency is the thing that stops law enforcement being abused for all kinds of reasons. And so the fact that it's actually the transparency aspect here that is broken is actually a huge deal.
Stephen.
Hi, Stephen Farrell. First, thanks. I thought that was a really good talk and pitched just at the right level for this crowd, so well done. Where should I go to look for some details about these perpetual hash functions? Typically, people talk about them, but they say some are secret, some are just code. Is there a good kind of reference to discussing their properties and how they work?
So it's quite a frustrating sort of corner because it really came mostly out of behind the scenes kind of industry. It didn't come, at least I certainly haven't seen a lot of scientific literature about it, which is why that weird definition was the best that I could do. The Facebook PDQ repository is very transparent with reference implementations for all kinds of things. You can just find it on GitHub.
Okay, that's a good answer.
That's my best effort.
Okay. Oh, okay. One last question. Online.
Well, hi, Vanessa. Good to see you again. I was going to say neural hash.
Oh, hi, Eric. How are you?
Good. Sorry, I couldn't make it. So neural hash has been reverse engineered and published. I'll put some links in the chat. And I think, but I think.
So you have to slow down as usual, Eric, because the little auto interpreter just can't deal.
And also speak up a little bit, maybe.
Sure, maybe this is better. So neural hash at least has been reverse engineered and published. I'll put some links in the chat.
Oh yes, please. Thank you.
The Apple one.
I mean,
there's a whole cottage
industry. Found an implementation, but
yeah, there was a whole cottage industry of building collisions when it first was done.
Okay, and with that, we are actually. I think he just wanted to provide some.
Oh, he wanted to answer the other person's question. Oh, great. Okay. Yeah. Thanks, Eric.
And with that, we are at the end of the session. So thank you again. I hope you all enjoyed it. I see that there's a lot of good feedback in the chat, and see you next time.
You got your phone back?
Yes, that's my phone.
Do you want to stop sharing?
Yeah, that's a good idea.
Yeah, you're done. Yep.
Hey. Yes, IAB Open in years. And it was excellent. The quality of the presentations, outstanding, pitched at the right level, and also giving people stuff to think about for the future. Outstanding job, and I hope you pass that on to your IAB colleagues. It was just a great job. Nice work.
We also have been a little bit lucky that we
Hi, can you hear me? Hello, anybody could hear me?